Welcome back. Today I'm going to give you part 2 of the lesson on triangle area. We did it with trigonometry last time with formulas such like area is 1/2 AB sine C or BC sine A and so forth. We went through those formulas. That worked really well when you're given two sides and the angle between. What happens, however, in an instance like this where you're given three side lengths? So, in that particular instance, I've got a triangle. I'm going to call it ABC, and where I put the sides really doesn't matter. I'm going to let little a equal 9, little b equal 12, and little c equal 7. It doesn't matter which side I call which letter. That's immaterial. But to do this, the problem with using that other formula I gave you in the last set of notes is that I don't know any angles, and with what I've shown you so far, you don't have a means whereby you can find an angle. Now, I can use law of cosines to find that, but that's our next lesson. I haven't shown you that yet. So what I'm going to show you how to do a problem like this requires something called Heron's formula. Let me show you what that looks like. Heron's formula basically says this: when I have a triangle where I'm given side, 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 or all three sides, quite simply what I do is find something called the semi-perimeter of the triangle. Semi-perimeter? Well, half of the perimeter. I find that by taking 1/2 of the perimeter, all the sides added up, little a plus little b plus little c. Once you find the semi-perimeter, you can find the area by taking the square root of the semi-perimeter times the semi-perimeter minus one of the sides times semi-perimeter minus another side minus or times the semi-perimeter minus the third side. So let's put that into play here. So in this case, what I'm given are three sides, which means I'm going to use Heron's formula. So first, I'm going to find the semi-perimeter, which means half of the three sides, 7 plus 9 plus 12, which is half of 7 and 9 makes 16, plus 12 makes 28, and half of that is equal to 14. That is our semi-perimeter, or half of the perimeter. Once I've got that, Heron's formula says that the area can be found by taking the square root of the semi-perimeter times semi-perimeter minus one of the sides, so 14 minus the side 7, semi-perimeter minus the side 9, semi-perimeter minus the other side 12. Let me go ahead and crank that out real quick on a calculator here. As far as I know, you're not in my classroom, you don't have access to my graphing calculators. If you have one of your own, great. If not, you can just use like a scientific calculator and you should be fine. Definitely I don't need trig to do Heron's formula, but for the last lesson we had to do sines and cosines. You can get that using just a regular calculator. So in this case, I take the square root of 14 and then times 14 minus 7, which is 7. 14 minus 9 is 5, and 14 minus 2 is 12, giving me an area of about 31.30. And I did not give you any units, so it would be units squared. Let's take a look at one last question, and that should be pretty much it. It's really not that hard of a concept to deal with. So in this particular case, I have Armando wishes to carpet a triangular shaped room. Yeah, I know, triangular shaped room, probably not feasible, but it works for our purposes. If the sides of the room measure 10 feet and 14 feet and 8 feet, so again, I'm dealing with 3 sides. That tells me if I'm looking to do in part A, find the area of the room, I'm going to use Heron's formula. So first, we find the semi-perimeter. I'm going to take half of the 10, the 14, and the 8, all added together, which is half of, let me see, 10 and 14 is 24, plus 8 is 32. That makes 16. So to find the area of the room, I'm going to use our Heron's formula, which says to take the square root of the semi-perimeter times the semi-perimeter minus one side, semi-perimeter minus the second side, and semi-perimeter minus the third side, which I believe is 8. And let's see what we get there. So go ahead and write down, do your thing while I'm calculating here. So I'm going to go square root of 16, and then 16 minus 10 is times 6. 16 minus 14 is 2, and 16 minus 8 is 8. And I get an area of about 39.19 square feet. Last part. Once I've got that, find the cost. Really simple. All I do is take the area, 39.19 square feet, and multiply it by the cost per square foot of $2.25. So if I take what I just found and multiply it by 2.25 here, I get a cost of about 88.18, or in other words, $88.18. I know that's awful cheap, but I'm just interested in the mathematics behind it. You know, maybe we can do a project later on a little more realistic application of it. But that's the basics here with Heron's formula, finding triangle areas with 3 sides. It's kind of easy. I hope it helps. Okay, thank you.